What is AEAD and why should you care? Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. Today, we're going to demystify AEAD encryption, a technology that protects billions of internet connections every day. Don't worry if you've never heard of it. By the end of this presentation, you'll understand exactly how it works and why it's so important. AEAD stands for Authenticated Encryption with Associated Data. To simplify, think of it this way. When you send a message over the internet, you want two things. First, you want it to be secret. Only the intended recipient should be able to read it. Second, you want to be sure it hasn't been tampered with along the way. Traditional encryption is like putting your message in a locked box. But what if someone swaps the box for a different one? Or changes the shipping label? AEAD is like having a locked box with a tamper-evident seal that also protects the shipping label. One simple operation gives you complete protection. Every time you connect to a website with HTTPS, use a VPN, or send a WhatsApp message, AEAD is working behind the scenes to keep your data safe. Let's explore how this elegant solution works, using simple analogies and clear diagrams that anyone can understand. The traditional approach. Why two steps aren't better? To understand why AEAD is brilliant, let's first look at how encryption traditionally worked. Imagine you are sending a valuable package through the mail. The old approach was like using two separate security measures that did not talk to each other. First, you'd lock your package in a box, encryption. Then, you'd put a wax seal on the outside, authentication. These were two completely separate operations, often using different keys and methods. It's like having one person lock the box and a different person add the seal, without them coordinating. This two-step approach has several problems. First, it's slow, because you have to process your data twice. Imagine having to pack every item twice before shipping. Second, it's complex, as you need to manage two different keys and make sure both operations happen in the right order. Get the order wrong, and you've created a security vulnerability. But the biggest problem is more subtle. When encryption and authentication are separate, there are gaps between them where clever attackers can cause mischief. It is like the moment between when the box is locked and when the seal is applied. What if someone swaps the box during that gap? Real-world example. Many older VPN protocols suffered from attacks where hackers could modify encrypted data in ways that, when decrypted, would execute malicious commands. The encryption was fine, the authentication was fine, but the gap between them was the vulnerability. This is why security experts realized we needed a better approach, one that combines encryption and authentication into a single, unified operation. Enter AEAD. The AEAD solution. One operation, complete protection. AEAD is elegantly simple. It combines encryption and authentication into one seamless operation. Let me explain with an analogy that makes this crystal clear. Imagine a special shipping service that uses magical boxes. When you put your items in and close the lid with your special key, two things happen simultaneously. The contents become invisible, encryption, and the box seals itself with an unforgeable signature that covers both the contents and the shipping label, authentication. Here's the clever part. The shipping label, what we call associated data, needs to stay visible so the postal service can deliver it, but it still needs protection against tampering. AEAD handles this beautifully. It authenticates the label without encrypting it. In the digital world, this translates to protecting your data and its metadata in one go. When you send a message, the actual content is encrypted, made secret, but things like the sender and recipient addresses need to stay visible for routing. AEAD ensures both are protected against tampering. The diagram on this slide shows how simple AEAD is from a user's perspective. You provide your secret message, any public data that needs protection, and a unique number for this message, called a nonce. Out comes your encrypted message and a special tag that proves everything is authentic. If anyone tries to modify even a single bit of the encrypted message or the associated data, the tag won't match when the recipient checks it. It's like our magical box refusing to open if anyone tampered with either the contents or the shipping label. This fail-safe behavior is what makes AEAD so secure. Understanding associated data, the brilliant innovation. The associated data part of AEAD is what makes it particularly clever. Let me explain why this innovation is so important using a real-world analogy everyone can understand. Imagine you're sending a birthday present to your friend. The gift inside the box needs to be a surprise, encrypted, but the happy birthday card on the outside and the delivery address need to be visible. However, you still want to make sure nobody changes that card to say "get well soon" or redirects the package to a different address. In networking terms, this is exactly the challenge we face. When your computer sends data over the internet, some information must remain visible for the network to function. IP addresses, like postal addresses, need to be readable by routers. Protocol information, like fragile stickers, needs to be visible for proper handling. Before AEAD, we had an awkward choice. Either encrypt everything and break network routing, or leave some data unprotected and vulnerable to tampering. AEAD solves this elegantly by introducing the concept of associated data, information that gets authenticated, protected against tampering, but not encrypted, remains visible. The diagram shows this in action. Notice how the associated data goes into the AEAD process and affects the authentication tag, but comes out unchanged and readable. Yet if anyone modifies it, the authentication will fail. It's like having invisible ink that marks both the package contents and the shipping label. You can't see the mark, but any tampering becomes immediately obvious. This innovation is why AEAD has become the standard for modern secure communications. It solves real-world problems elegantly without compromising security or functionality. The magic of the nonce, keeping every message unique. Now let's talk about a critical component of AEAD that often confuses people, the nonce. Don't let the technical name intimidate you. A nonce is simply a number that should be used only once. Think of it like a serial number for each message you send. Why do we need this? Let me explain with a simple analogy. Imagine if every time you sent the same message, it looked exactly the same when encrypted. An attacker might notice patterns. Oh, this encrypted blob appears every morning at 9 a.m. It must be the daily report. That's not very secure. The nonce ensures that even if you send the exact same message twice, the encrypted version looks completely different each time. It's like adding a unique timestamp to each message before encryption, ensuring every output is unique. Here's where it gets interesting. With AEAD, reusing a nonce with the same key is catastrophic. It's not just bad practice, it completely breaks the security. Think of it like using the same lottery ticket number twice. The system is designed on the assumption that this never happens. The diagram illustrates how the same message with different nonces produce completely different encrypted outputs. This is crucial for security. In practice, systems use counters like 1, 2, 3, and so on, or random numbers as nonces. The key rule is simple. Never repeat a nonce with the same key. This might seem like a weakness, but it's actually a strength. By requiring unique nonces, AEAD forces good security practices. It's like a safety mechanism that ensures every message is protected with fresh randomness. Modern systems handle nonce generation automatically, so users don't have to worry about it. How AEAD protects your data. The complete picture. Let's put all the pieces together and see how AEAD protects your data from start to finish. I'll walk you through a complete example that shows why this system is so secure and elegant. Imagine Alice wants to send Bob a confidential business proposal over the internet. The proposal itself needs to be secret, but the email headers, from Alice to Bob with the subject business proposal, need to be visible for the email system to work. When Alice hits send, here's what happens. First, her email client generates a unique nonce for this message. Think of it as a unique ID number that will never be used again. Then, it feeds 4 things into the AEAD algorithm. The encryption key, shared secretly with Bob. The nonce, the email body, plaintext, and the email headers, associated data. The AEAD algorithm works its magic in one smooth operation. It encrypts the email body so it looks like random gibberish to anyone intercepting it. Simultaneously, it computes a special authentication tag that covers both the encrypted body and the headers. This tag is like a cryptographic fingerprint of the entire message. The encrypted email travels across the internet. The headers remain visible so email servers can route it properly, but both the headers and the encrypted body are protected by the authentication tag. If a hacker tries to change the recipient from Bob to Eve, or modifies even one bit of the encrypted message, the tag won't match. When Bob receives the message, his email client reverses the process. It checks the tag first. If anything was tampered with, it rejects the message entirely. Only if everything checks out does it decrypt the message. This authenticate then decrypt approach ensures Bob never sees corrupted or tampered data. Real-world AEAD. Where you're already using it. You might be surprised to learn that you're already using AEAD encryption dozens of times every day. Let's look at where this technology is protecting you right now, often without you even knowing it. Every time you see that padlock icon in your browser, AEAD is at work. Modern HTTPS connections use AEAD ciphers like AES-GCM or ChaCha20 Poly 1305. When you log into your bank, shop online, or check social media, AEAD ensures that your passwords and personal data can't be intercepted or tampered with. Using a VPN for work or privacy. Modern VPN protocols like IKEV2 and WireGuard rely on AEAD. Your entire internet traffic is wrapped in AEAD protection, creating a secure tunnel between your device and the VPN server. The beauty is that network routing information, associated data, remains visible to get your packets to the VPN server, while your actual browsing, the payload, is encrypted. Messaging apps like WhatsApp, Signal, and iMessage use AEAD for end-to-end encryption. When you send a message, AEAD ensures that only the intended recipient can read it and that the message hasn't been modified. The metadata needed for message delivery is protected as associated data. Even your Wi-Fi uses AEAD. The WPA3 security standard employs AEAD to protect your wireless communications. Every packet between your device and the router is protected against both eavesdropping and tampering. The diagram shows how pervasive AEAD has become in our digital lives. From the moment you wake up and check your phone to when you stream a movie before bed, AEAD is working silently in the background, protecting your digital life. It has become the gold standard because it solves real problems elegantly and efficiently. AEAD versus traditional encryption. A clear comparison. Now that you understand how AEAD works, let us compare it directly with traditional encryption to see why it is such an improvement. This comparison will help you appreciate why the tech industry has embraced AEAD so enthusiastically. Imagine traditional encryption as hiring 2 different security guards who do not communicate. One guard, representing encryption, locks your valuables in a safe, while another guard, representing authentication, places a seal on the safe. These guards work independently, use different keys, and do not coordinate their efforts. This approach creates inefficiencies and potential security gaps. AEAD is like hiring a single, highly trained security expert who handles both jobs seamlessly. This expert uses one key and performs both tasks in a single, coordinated action. The result is better security, faster operation, and simpler management. Performance-wise, AEAD is dramatically better. Traditional methods require 2 passes over your data, once to encrypt and once to authenticate. That's like reading a book twice to accomplish what could be done in a single reading. AEAD processes your data just once, which is why it's often 2 to 3 times faster. Security is also superior with AEAD. Traditional methods can suffer from subtle vulnerabilities depending on how encryption and authentication are combined. Should you encrypt then authenticate or authenticate then encrypt? Get it wrong, and you have created a weakness. AEAD eliminates this problem entirely. There is only one correct way to do it. The comparison table on this slide shows the dramatic differences. Notice how AEAD simplifies every aspect while improving both security and performance. It's a rare win-win-win situation in technology, which is why AEAD has become the standard for modern encryption. Common AEAD algorithms. Choosing the right tool. Not all AEAD algorithms are created equal. Let's look at the most common ones you will encounter and understand when each one shines. Think of these as different tools in a toolbox. Each has its ideal use case. AES-GCM is like the Swiss Army knife of AEAD, versatile and widely supported. It is based on AES, the encryption standard used by governments worldwide. The GCM part stands for Galois/counter mode, but all you need to know is that it is extremely fast on modern processors. If your device was made in the last decade, it probably has special hardware to accelerate AES-GCM. Cha-Cha 20 Poly 1305 is the sports car of AEAD algorithms. It is designed for pure performance in software. Created by cryptographer Daniel Bernstein, it is optimized for devices without special hardware acceleration. Your smartphone, smart TV, or IoT devices probably use this because it is fast and energy efficient without requiring special chips. AES-CCM is the conservative choice, often found in Wi-Fi routers and Bluetooth devices. It has been around longer and uses simpler mathematics, making it easier to implement in resource-constrained devices. Think of it as the reliable family sedan, not the fastest, but dependable and well-tested. The newer algorithms like AEGIS and ROCCA are like concept cars, showing us the future of encryption with even faster speeds. They're not widely deployed yet, but they demonstrate that AEAD continues to evolve and improve. The visual comparison shows how these algorithms differ in speed and use cases. The key takeaway is that modern systems often support multiple AEAD algorithms and automatically choose the best one for your device. You get optimal security and performance without having to think about it. The future of AEAD and what it means for you. As we wrap up our journey through AEAD encryption, let us look at where this technology is heading and what it means for your digital security in the coming years. The future of AEAD is bright and evolving rapidly. Quantum computers, which could break many current encryption methods, won't affect AEAD algorithms themselves. They'll remain secure. However, the way we exchange keys will need to change, and AEAD is flexible enough to work with new quantum-resistant key exchange methods. We are also seeing AEAD expand beyond traditional uses. New applications include securing IoT devices in your smart home, protecting autonomous vehicle communications, and enabling secure cloud computing where even the cloud provider cannot see your data. AEAD's efficiency makes it perfect for these resource-constrained environments. For you as a user, the future means even better security with less impact on performance. Newer AEAD algorithms are being designed to be even faster and more energy efficient. Your devices will last longer on battery while providing stronger security, a win-win situation. The key takeaway from this presentation is that AEAD represents a fundamental improvement in how we protect digital communications. By combining encryption and authentication into one elegant operation, it provides better security, faster performance, and simpler implementation than traditional methods. Next time you see that padlock in your browser, connect to a VPN, or send a secure message, you'll know that AEAD is working behind the scenes. It's a beautiful example of how good cryptographic design can make our digital lives both more secure and more efficient. The best security is the kind you don't have to think about, and that's exactly what AEAD provides. Thank you for your attendance. Please consider subscribing to the channel.